The coefficients of the variables in the polynomial function must be non-negative integers. That is false, because we can have a polynomial function with negative 2x power 4 plus negative x cubed minus 4x minus 16. So the powers should be positive, but we have no condition for the coefficients. So this is a false statement. The graph of the polynomial function may have a gap or a break. Polynomial functions are continuous. There's no gap or a break. So this is a false statement. Use the leading coefficient test to determine the end behavior of the graph of each of the functions. So the leading coefficient here is the term with the highest power. In this case, our leading coefficient is 5 because the term with the highest power is x cubed and the coefficient of x cubed is 5. So let's go ahead and see the leading coefficient test. In the leading coefficient test, we need two things: the highest power and the coefficient of the highest power. The coefficient is 5. I'm only looking for the positive or the negative. So 5 is positive, and the highest power is 3, which is odd. Since the leading coefficient is positive and it is odd, the graph would be, the end behavior of the graph would be something like this. On the right hand side, the graph would increase. On the left hand side, the graph would decrease. The function is in the factored form, but we can determine the degree and the leading coefficient without multiplying it out. So here, I would go ahead and look at the first terms. So negative x squared is this term, times x, which is this, times x. So here, my leading term would be negative x cubed. And then again, in the leading term, what do I look at? Just the power. The coefficient is negative, which is negative 1. The coefficient is negative. And the power is 3, which is odd. So it's an odd degree polynomial with a negative power. So it would be, the graph would be something like this. No, it's x. It's even power. Did I say x cubed? It's even power. This is again even power. Because x squared times x gives me x power 4. So it's an even power with negative. So it's simply going to be the opposite of even power and positive. So my graph would be something like this, going down on both sides. Remember, we're just talking about the end behavior. So it's negative and even. So my graph would be like an inverted parabola. Find all the zeros of the polynomial. How do I find the zeros of the polynomial? Zeros of the polynomial are nothing but the x-intercepts of the polynomial. So how do I find x-intercept? I set f of x equal to 0. So x cubed plus 2x squared minus x minus 2 equal to 0. I see 4 terms, so I work with the first 2 and then the last 2. From the first 2 terms, I can factor x squared. So I have x plus 2, and I can factor negative 1, so I have x plus 2 equal to 0. X squared minus 1 and x plus 2 equal to 0. I can further factor x squared minus 1 to x plus 1 times x minus 1 and x plus 2 equal to 0. So each of them, setting each of them to 0, if I set x minus 1 to 0, I get x is equal to 1. If I set x plus 1 to 0, I get x is equal to negative 1. If I set x plus 2 is equal to 0, I get negative 2. So plus 1, negative 1, and minus 2 are the zeros of the polynomial. Find the zeros of f of x and give the multiplicity of each zero, and state whether the graph crosses x-axis or touches x-axis and turns around. So now, to go ahead and find the zeros of the polynomial, we need to factor it. But this is already in a factored form for us, so we don't have to go ahead and factor it. So what I do is Finding the 0 is the same as finding the x-intercept. So you're going to set it equal to 0. 0 is, this is a positive 4, x minus 3 times x plus 6 cube. So I have setting each factor to 0. X minus 3 is 0. X plus 6 is 0. So I have x is equal to 3 and x is equal to negative 6. And here 3 has a multiplicity of 1 and negative 6 has a multiplicity of 3. Because the multiplicity of 3 is 1, which is odd, it simply crosses the x-axis. And the same is the case with here. Because the multiplicity of negative 6 is 3, which is odd, it simply crosses the x-axis. If the multiplicity was even, then the graph turns over. Okay? But in this case, both have odd multiplicity, and the graph simply crosses at 3 and at negative 6. Show that the polynomial function f of x, 2x power 4 minus 4x squared plus 1, has a 0 between negative 1 and 0. According to the intermediate value theorem, if you have two values, a and b, in this case a is negative 1 and b is 0. If you have two values a and b, and f of a and f of b have opposite signs, then there is a real 0 between negative 1 and 2. So in this case, f of a is f of negative 1 and f of b is f of 0. So let's go ahead and find what f of negative 1 is. F of negative 1 would be 2 times negative 1 power 4 minus 4 times negative 1 squared plus 1. So that is 2 minus 4 plus 1, which is negative 1. And f of 0 is 0 power 4 minus 4 0 squared plus 1, which is 1. So you see that f of negative 1 is negative and f of 0 is positive, because the sign change between f of negative 1 and f of 0 shows that there is a real 0 between negative 1 and 0. The greatest number of turning points of a graph of a polynomial degree n is n minus 1. So here the degree is 4, so greatest number of turns would be 4 minus 1, which is 3. Use the 5-step strategy to graph x power 4 minus 9x squared. Step 1 is to check for the end behavior. Since f of x power 4 minus x squared is an even degree polynomial, and since the leading coefficient is 1, which is positive, the graph would be something like this. The end behavior of the graph would be something like this. Number 2, x-intercept. How do I find x-intercept? I set f of x equal to 0. That is x power 4 minus 9x squared equal to 0. Factoring out x squared, I have x squared minus 9 equal to 0. So I have x squared times x plus 3 and x minus 3 equal to 0. Applying the zero product principle, I have x squared is equal to 0. That means x is equal to 0. X plus 3 equal to 0. That means x is equal to negative 3. X minus 3 equal to 0. That means x is equal to 3. So the zeros of this polynomial f are 0, negative 3, and 3. So the graph touches x-axis at these points. Now let me go ahead and look at the multiplicities. Because the multiplicity of 0 is 2, the graph turns around at 0. So at 0, the graph turns around because the multiplicity is even. At 3, the multiplicity is odd, so the graph crosses x-axis. At -3, the multiplicity is odd, so the graph simply crosses x-axis. Step 3 is to find the y-intercept. How do I find y-intercept? I set x equal to 0. So 0 power 4 minus 9 times 0 squared is equal to 0. That means the graph passes through the origin 0, 0. And step 4 is to find the symmetry. And because this is x power 4 minus 9x squared, I'm going to find f of negative x, which is negative x power 4 minus 9 times negative x squared. That is x power 4 minus 9x squared. Since f of negative x is equal to f of x, the graph is even. The graph is even. I mean, symmetry along both sides. It's an even function. So now let's go ahead and draw the graph. The x-intercepts are 0, -3, +3. So this is my end behavior of the graph. This is the end behavior of the graph. At -3, the multiplicity is odd, so the graph simply crosses. Remember, it has to touch the other x-intercept. At 0, the multiplicity is even, so the graph turns around and it has to go back to the other x-intercept. And remember, at 3, the multiplicity is odd, so the graph simply crosses. That is the final graph. So this is 0, 3, -3.